This is section 1.4, Powers and Exponents. Let's do a quick warm-up on just multiplying some numbers together, which would be how the expanded form of exponents would look. So the first thing I have here is just 2 times 2. 2 times 2 is 4. The next one I have here is negative 2 times negative 2. A negative times a negative is a positive. 2 times 2 is 4. The next one I have negative times a negative times a negative. The other day I mentioned if you have an odd number of negatives, your answer is negative. 2 times 2 is 4, times 2 is 8. The next one, 3 times 3 times 3. 3 times 3 is 9, times 3 is 27. And the last one, negative times negative is positive. 2 times 2 is 4, and 3 times 3 is 9. So again, the answer of 4 ninths. Today, we're going to start to talk about those powers and exponents. So a power is an expression that can be written as with an exponent, and it has a base. So if you guys look at this, this is the base, and this little 2 is the exponent. The entire thing is called a power. Alright, the first thing we're going to talk about here is using some geometry. When a number is raised to the second power, we usually say it's squared. The area of a square is s times s, or s to the second power, s squared. When a number is raised to the third power, we usually say it's cubed. The volume of a cube is s times s times s, which is equal to s to the third power. So area squared, volume is cubed. So what we're going to do is write the power represented by the geometric model. This just is a cube, so we're going to say it's 5 times 5 times 5, but we're going to represent it by a power, so we're going to say it's 5, that's my base, to the exponent of 3. In example number 2, I'm going to write the power represented by the geometric model. This is just an area problem, so I have 6 times 6. That would be written as a base of 6 to the second power because there was 2 6s. The next problem here, we will say that this is a 2 by 2. So 2 times 2, or 2 to the second power. And the last one here, I have a cube again, x times x times x, or x cubed. Alright, when we're reading exponents, we want to say 3 to the first power, which would be like a 3, or 3 to the power would look 3 to the first, the value is 3. We can read 3 to the second power, or 3 squared, 3 times 3, which is 3 to that little exponent of 2, which is equivalent to 9, or 3 times 3. 3 to the third power, or 3 cubed, is 3 times 3 times 3, or 3 to that little 3. 3 times 3 times 3 is 27. And then you can continue to read here, 3 to the fourth and 3 to the fifth. Please be very cautious of this. In the expression negative 5 squared, 5 is the base because the negative is not in parentheses. So there's 2 problems here. We could talk about negative 5 squared, and we can talk about negative 5 squared. This one says write negative 5 times negative 5, which gives you an answer of 25. However, this one says write the 5 times the 5, carry along the negative. So this answer would be negative 25. So we may need to have a discussion about this during class. Please bring questions if there are any. Let's look at these a little bit more and look at the caution and understand maybe a little bit more the difference. Again, this whole thing is to the third power, so I'm writing the negative 3 times as well as the 6 3 times. A negative times a negative times a negative is a negative answer. 6 times 6 is 36 times 6 is 216. On the other hand, this one just says the 10 is written twice. The negative is written, and then we have 10 times 10. Negative 10 times 10 is negative 100. Okay, so why don't you try this one on your own to see if you understand the reasoning behind it. Pause it if you need to. So my answer for this one would be negative 5 times negative 5 times negative 5. Negative times a negative times a negative is a negative 125. On the other hand, I have this one, which says negative 6 times 6. This one is also a negative answer of negative 36. Alright, at this point we'll go ahead and pause and we'll come back to some more of these powers on the second video.